Towel. Yeah, today let's check this type of crane called the Sheerleg. Maybe before going far, let me start by differentiating what we call the true length and untrue length. So true length is any distance between points that is not foreshortened by the view type. Okay, so let me start with the top view so to make sense. When you look at this thing from the top like this, in drawing, when you draw the top view, you are going to draw a line like this. You're going to draw something like this, starting from here up to there. So, which will represent the length of this marker when you look at it from the top. So, in other words, the length of this marker will appear to be shorter than in real. Therefore, we say that the length of this marker starts from here to there when we look at it from the top. But this length, we're going to call it untrue length. So to get the true length of this marker, we have to put it down like this. So it doesn't matter whether it's at an incline or angle or whatever, as long as it's lying flat, you will see the true length. So the true length of this marker is this. It's this size. So it's this size compared to this one. So this one we call it the true length. So as you incline this, then the length of this marker starts to appear shorter because of this view, because of this top view. So I was just trying to differentiate between the true length and untrue length. So the crane that we're going to talk about, Sheerleg, it's something like this. This is the leg. This is the leg. It's going to have two legs, and then it's going to have this one, the third member, which we're going to call it the backstay. So this crane will be used to lift the load, which will be hinged here. This point we're going to call it apex. Then the load will be supported or hinged there. So this thing can move like this. So as it moves like this, this backstay here will be going backward and forward like that. And then in that way, the load can be moved from this position here to this position. So as this thing goes like this, the load can be shifted from one point to another point. So for the load to go up, the upward movement doesn't really depend on this, the movement of this. The upward movement is lifted by the cable. There will be a cable that will be attached here, and then if you want and then that cable will be attached to the motor. So if you want to raise the load upward, you just have to rotate the motor maybe in clockwise. If you want the load to go down, you rotate the motor in an anti-clockwise direction. So our main goal here is to determine the force in each leg as well as in the backstay. These are the legs that we're talking about. This is the backstay. So as the load will be supported here, that load is going to push downward. So this marker will have to resist, this one will have to resist, apply force in opposite direction. So even this one, as the load or as this thing goes down, as the load pulls down, this white member will be stretched. So otherwise, if this member doesn't pull in that direction, the backward direction, these two legs will just fall like this. So for the fact that this thing remains like this, it means that this white member is pulling these two in that direction. Therefore, it means that this white member will be external will be pulled like this, but it will apply a force in opposite direction, the internal force. So this member will be under tension, and then any member under tension will be tight. These two, this one and this one, will be under compression. They will be compressed, so they will be pushed downward like this. In that way, they will be compressed. Then any member under compression, it's a strut. So that will always be the case. Right, we're going to start by drawing the top view and the front view of this crane that you see here. So we're going to take this position and this angle. So if you look at this thing from the top, what we're going to see is that we're going to see something like this. This is the top view. It's straight, it's fine. But this marker and this marker, the length of these two markers, since they are at an angle like this. Okay, if this thing stands like this, you won't see the true length. For you to see the true length, we have to put this thing down. So as this thing goes up by an angle, the length of this marker gets shortened by the view. So meaning that the actual length of this marker is not this size. So if you want to know the actual length of this mark, we have to put this marker down from this, which will be this size. If you put it down, you will see the length will become bigger. Therefore, what we're going to see here, the length of this and this, as we draw the top view, will be shorter. So we say that the length of this and this, they are untrue length. So this is what we are going to see, is untrue length. It's shortened by the point of view. We're looking at it from the top. So our top view is going to make this thing to appear as if it's shorter, but we know that the length of that is not that short. Right. So we are going to draw. Okay, as I've said, that if you want to know the true length, or if you want to see the true length of this marker, you must put this marker down like this. So we are going to take these markers like this, because now we want the true length of these markers. We are going to put them down like this. So when you put them down like this, now you can see the length of these two markers starts to increase when we check it from the top. So if they're like this, the length will be this size, but as you put them down, the length in between my fingers starts to grow now. So this is the true length. So from this sketch, what we are seeing is when this thing is like this. So now we're going to put this thing down in order to see the true length. Then after putting it down, we're going to have this. So in other words, as well, on the diagram, we are going to take those markers and lie them down. Then if you lie them down like that, you will have this. So these black ones will represent the true length, which is now longer. So this red one is when it was like this. It's shorter, and then when you put it down, you will see the longer length. So which is this black one there. Right, now we go to the top view. Unfortunately, my camera is on the top view, but it's fine. I can try to I will try to move it to the top view. Yeah. So I'm going to shift my camera to the side view so that you can get what I'm talking about. Okay. Unfortunately, I'm alone here. I don't have enough hands. But if you look at this thing from this side, that's what we are going to see. We are going to see something like this. So that will be the front view. This is what we are seeing now. You must arrange this thing in such a way that when you look at this, you will only see this feet, you won't see that other feet there. Yeah, something close to this. You can see the red marker, you don't see the black one there. So from this view, when this is your front view or your side view, but let's say it's a front view. Therefore, what you are seeing now, I'm going to draw it there. So we've just seen that the front view will be something like this. This is that load or that rubber band. So this is the front view. Then that is the starting point. You draw the top view and the front view. But we don't just draw them. Even so that we know that the front view will exactly be this, and then the top view will exactly be this. We need some angles and some measurement or some length. Therefore, I'm not going to draw this because I know from experience it's going to take a lot of time. So I'm just going to explain an example from the book. Like this, I've already discussed the front view and the top view. So you can read the question now. Okay, from the question, they're telling you that the length of the backstay, which is this, is 15, as you can see it there, and the two legs each 12 meter long. The length of this leg and this leg 12 meter long, and the apex of the sheer leg overhangs the hinges of the legs by 6 meter. So is this part here. This part, as I've said, this one is the apex, and then these legs, they are hinged here. So it means that the distance from here, from the hinge where these legs are hinged or fixed to the apex, to there, it's 6 meter. Okay, which is this distance here? From here to the apex, it's 6 meter. Okay, in this case, which is the distance from here to there, or the distance from here to there. So is this one here. The load, okay, sorry, before that, the legs are placed 12 meter apart, and the apex of the sheer legs overhangs. Oh yeah, okay, these two legs is this one and this one. They say the distance between this leg and this leg is 12. It's fine, which is from the top view, the distance between this and this one is 12 as well. Good. The load lifted in this position is 20 kN. Determine the force in each leg as well as in the backstay also state whether each member is a tie or a strut. So I've already spoke about that one. I said this one will be under tension, this two will be under compression, and then is this part. That backstay will be tie or will be under tension. This one will be strut since they will be under compression. Right, so the first step here is to start by drawing this part because we have enough information for this. Remember they said that this length and this length, they are separated by a distance of these legs, a distance of 12, which is this. So the distance between this and this must be 12. So you take your ruler, mark 12 meter, but you have to use your own scale now. So I don't know, you can say, let me see, where's my ruler? One, two, three, four, five, six. Yeah, I can see. I think 6 centimeters will be reasonable. Then we can say let 12 meter equals to 6 centimeter, or we can say let 2 meter equals to 1 centimeter. So 1 centimeter will represent 2 meter. Therefore, you draw a line and then you make it that line to be a 6 centimeter. Draw it vertically like this, and then from there they told you that the distance from here to there is 6 meter. So in your case it means that it will be 3 centimeter. So you mark a distance from here to there 3 centimeter. Maybe we'll be having this. You mark from here to there, that is that 12. Mark from here to there 3 centimeter. Then from there you can just cut this line into half. Since it's 6 centimeter, you mark 3 centimeter from here to there, 3 centimeter from here to the center of this line. Then from there you draw a horizontal line like this. Then from there you can just join this line like that and like that. So yeah, these ones are just the construction lines. So remember, we are drawing the top view of this. So we're drawing the top view of this. There is nothing here. So that's why you won't have that line. There is nothing here. Good. Then after that, as I've shown you, you are going to draw the true length of these legs, of these two legs. So to draw the true length of these two legs, as I've shown you, you are going to lie those markers or those legs down. Then as they lie down, the length from your view will get longer, which is this dotted line. But you know that the true length of these markers or of these legs is 12 meter. So it means that yourself, since you know that the true length of these markers is 12 meter, you just have to take this compass and then go to your ruler and then set a distance of 6 centimeter like this. Then after doing this, remember you will be having this. You will be having this, which is this. After that, you come here at this end, you draw an arc. And then you come to this other end, you draw an arc. Like that. And then they will meet somewhere here. Then where they meet, you will join this, like this, like this. So get this part and this part. To get this D, you use the compass as I've shown you. Then that is almost the top view, but it's not yet done. So from the top view, we only managed to draw these two, 1, 2, and then when we put it down. So now when we check this thing from the top as well, we're going to see this white thing, which is that backstay. Let me put it like this. But now our challenge is that we don't know the length of this from here to there. Yes, we know the length of this backstay is 15 meters. But when you look at this backstay, this white thing here, from the top like this, it will appear that this thing is shorter than 15 meters. So that 15 meters that they spoke about here, there, is this length. It's this much from here to there. But as you raise this thing, the length will start to appear shorter, maybe to this size. It will start to appear shorter. So now, this length that we see here between my fingers is the one that we have to draw here. So which we don't know. We don't know that length. So we only know the true length of this. We don't know untrue length. So now we have to find this untrue length. So to get this untrue length, we're going to use this approach. Remember, now you will be having this point, and this point. So what we have to do from here is we have to draw the horizontal line like this. Make sure that this line is parallel to this. Then from there, so you draw a line up here like that, and then you project this point, this one upward, to project it through. Take ruler, you place it vertically, and then you project this point like this. Remember, here is A, here is B, here is O, and then here we can say is D. So D, O. Remember, when you check this thing from the front, which is what we're going to draw now here, we're going to draw the front view. When you check this thing from the front, A and B will be on the same point. As I've shown you, or you won't see, you will only see the first marker from a side, the other marker you won't see it. So A and B will be on the same point, which is this. Okay, anyway, I'm here. You project those points like this. Then from there, you come to this point. Then you put your compass there, like this. From here to D. And then after that, you draw an arc like this. So you extend this line, as this line represents the apex, or where the load will be hanged. You extend it upward like this. And then where this curved line will cross this vertical line, that's where you are going to have this point O. That's why you are going to have that point O. So now you will be having this point O now. And then from there you can just join this line A, B, and O. Then from there you have to find this point C. So to find this point C, which is going to give us that untrue length of the backstay, you just have to remember, we know the true length of this thing. Remember, this is the front view. So when this marker is like this, I mean this, let me use the marker. When it's like this, when you look at it from the top, you will see untrue length. But when you look at it from the front, this untrue length one, I mean, you will see the real length or the true length. So whether it's like this or like this or like this, if you view it from this side, you will see the true length. So don't be surprised now here. We're going to use the 15 meter, which is the true length of this. Why? Because we are looking at this thing now from the front. This is the front view. The only time you won't see the true length is when you're looking at it from the top view. So now you go to the ruler using your scale. I'm not sure, remember our scale, I'm not sure. Okay, 14 will be equals to 7 meter, then it means that 7.5. Yeah, 15 meter will be equals to 7.5 centimeter. You come here and set 7.5 centimeter, maybe like this. Then after that, you come and put that thing here, this here, and then you draw an arc. So when you draw an arc, where this line will cross this horizontal line will be your C, which is this point. And then after getting this, you draw this dotted line going down. Then where this line will cross the horizontal line, you can just draw the horizontal line here on this edge, from these two edges like this. Then where this dotted line will come in contact with those dotted line will be C. Then in that way, that's how you'll get the length of this backstay from the top view. Now we are done with the front view and the top view. Now we go to what do you call it? Is it vector diagram or force diagram? Let me just call it the force diagram. So now we want to know the magnitude of the force that will be carried by each member, and to end the backstay as well. Right. So far we've drawn those front views and the top views according to scale. I'm talking about this part. When we're doing this, we were using the measurements 12, 6. So everything is drawn according to scale. Now, this thing that we see here is the same as this one. Okay, we're going to use this. We've drawn it before. You don't have to repeat it. You don't have to repeat it. You can only draw it once like this. You don't have to draw it again here. Okay, from here, you will from frameworks at N5, you can still use that method of naming the spaces. Let me say this space is A, this one is B, this one is C. Then we normally start with the known member or the known member, the known force, or with the external forces. So where you start, you have to move clockwise. If you start with this member, you have to come to this member and this member. Right, from here, you start from A to B. Between A and B, there will be a member or a load going down with the magnitude of 20 kN. So we are going to use a scale, choose the suitable scale that will represent the force and this distance that we see here. I can make this 4 centimeter. So for this to be 4 centimeter according to this, then you can simply say let 1 centimeter equals to 5 kilonewton. So 20 divided by 5 is 4. So you make this one from here to there. Take your ruler vertically straight, and then you make it 4 centimeter. I don't have to make it since I'm just giving an explanation here. 4 centimeter like this. And then this line will be representing this force here, which is between A and B. Then we're going to call this member A, B. So after that, you come to this member, which is between B and C. Okay, since I've said that this thing is the space, we use the space diagram Then as you can see from this diagram, we have A and B. Then now we have to find the C. We have these two spaces, B and A. A is covering this space starting from here up to there. That space we call it A. Then this space is B. Then this space is C. Now we have to find this space on the first diagram. We have A and B. Now we have to find this space. So to find the C, we are going to use this adjacent space, which is B, and this one, which is A. This space here is A, this one is B. Therefore, you are going to say that B and C, it's separated by a line going at a certain angle. So from B, if you want to find the C, you will have to draw a line parallel to this line. So meaning that the angle of this line must be the same angle with that one that we are going to draw now. And then that line we are going to draw it from where? From B. So what we have to do now, we've got two methods of doing this, but I'm going to show you this one. I'm going to show you both actually. You measure this angle here. It's 10, 20. It's giving me about 55. Okay, 55. Then you come to B here. Here is B. And then you mark an angle of 55 somewhere here. Then after that, you extend this line like this. So this angle must be 55, which is the same angle as this one, which is 55. So this line is parallel to this line. So we want to find the C, then from B we draw a line parallel to this. Here's B, we draw a line parallel to this. Then again we are looking for C, then we are going to use this adjacent space as well, which is A. Then if you want to find the C from A, we are going to draw a line parallel to this line from A. This is A. From A, we are going to draw a line parallel to this. C and A, they are separated by this line. Therefore, from A, we have to measure this angle here. Somewhere here, almost 35. Then you come here, you put your protractor here, measure 35, it's somewhere here. Then you draw a line, project it, you draw it like this. Then since they don't meet, you can extend this one as well, like that. Then where they meet is that point. Where they meet is what? Is C. Then you put C there. You put C. The other method that you can use these set squares. Let me see if I can have them. I only have one here. Yeah, I have these two. Yeah, normally I don't use this. I normally use those ones of protractors. But anyway, yeah, you will be trying to draw. If you want to draw a line parallel to this, a line parallel to this, then you put your ruler like that, and then you put this other ruler like that. So it's just that my books are not at the same angle together with my table, and these two as well, they are not at the same angle, but that's why they will have this. But if they are accordingly, let me just try to put them straight according to this table here. Yeah, then that's how you'll draw the parallel line. So this line here, as you can see, is parallel to this. So that's how you can draw the parallel line. So it's the same thing. That's when you don't want to use your protractor, you can draw it like this. Then if to find the parallel line of this, let me put the book straight as well so that we don't experience the same thing. To draw the parallel lines of this, you put your ruler like this, and then this line now will be parallel to this. So that's how you can construct this line without using the protractor. Yeah. Then from there, you measure. Okay, this is AC. AC ke backstay. AC, according to me, AC, it's a backstay. So this length we measure from here to there will represent the force in backstay. So you measure this and multiply it by your scale. So you will have about 8.2. Then you take that 8.2, you multiply it by your scale there. Then it will give you a force in the backstay. I'm looking for the calculator here. Yeah, it's fine, let's leave it. But you will confirm it. This thing is not that accurate. This one, it was almost a rough thing. Then when you will get, maybe we'll get 7 point something or whatever. Okay. After multiplying this length that you will get here by your scale or 5, you will have to get this magnitude of 33. So now BC is what? Here's BC according to my sketch or spacing, BC. So BC is what? Is the leg. This is the leg. But this one is not, we don't only have one leg here, we've got two legs. So it means that this length, starting from here to there, multiplied by the scale, will give you the force that will be carried by the two legs. So the force that you will get there will be the force that will be exerted or that will be carried by these two legs. So that's why we are going to say that force that we'll get here will be the resultant. In legs. So both two legs will share or will carry this much. So now we have to find the force that will be carried by each member the force that will be carried by each member. So to get the force that will be carried by each member, you do this. You measure this length from here to there. In my case, it's 11 centimeter. Then you come here, draw 11 centimeter from here to there. I'm just doing a rough thing here. 11 centimeter like that. After that, you are going to use this true length of the legs. Yes, the true length of the leg, true length of the leg. So we are going to use this true length of the leg to find what? To find the force that will be carried by each member. So we are going to do that by drawing lines parallel. I'm running out of if you put this thing like this, parallel there, then you come and put this ruler like this. The line that will come out here will be parallel. This line here will be parallel to that part there. But anyway, I don't have enough space here, and then this thing as well needs to go that side. Unless if I turn it like this, yeah. If I turn it like this, it's going to work. So it's that method of the rulers. I'm trying to put this straight as well. Okay, you put this surface or edge to be parallel to this dotted line. Then you come here and put your ruler like this. So any line that will be here, you draw it here or here. As long as this ruler is in contact of this line will be parallel to that. So you can do this, move this thing until this ruler is in contact with this edge here. Then you draw like this. You draw like this. So this line will be parallel to that. Like that. Then from there, you can do this as well, parallel to this. Then you put your ruler like this. Then you move it down like this. And then where from this end you draw a line like this. So this line will be parallel to this. This one will be parallel to that. Then they will meet somewhere here. So you will measure the distance from here to there and then multiply it by your force scale. Then this distance from here to there will give you the force that will be carried by this member BD, the leg BD, which is this leg on this side, which will be this red leg. Then if you want to know the force that will be carried by this black red, it will be represented by AD. Then since this line is parallel to AD, then this line will give you the magnitude of the force that will be carried by that marker, the black marker, AD. So if you don't want to use this ruler method, you can still measure the angles. You can divide this thing into half like this and measure this angle here like that. So this angle will be about 30 degrees. Then you come here, measure 30 degrees. You measure 30 degrees and then you mark it there. Remember, I'm just doing things rough here. I'm just doing things rough. And then you measure this angle as well here. It will be the same. It will also be around the 30 degrees. Then which will be this. This is parallel to this. So to draw this as well, then you have to make this line to go with the angle of 30 degrees. So if this is 30, this is 30 as well. Alternate angles equal Z. This angle is 30, this one will be 30. This one 30, this one will be 30. So the 30 will be here, this one will have to be 30 as well. So you put the protractor there, measure 30, and then it draws the line. So that is an alternative way. Then from there, you are done. You measure this from here to there, you multiply it by the scale. You should get around 27.4, and even this side as well will get the same length. Actually, as long as these legs are equal, if these two legs, this one and this one, are equal, and then this thing is crossing in between exactly at the center, the backstay, then the force in this member and this member will be equal. Yeah, I think that's all. Thank you very much.